Ever just stumble into an art gallery, and think, this is amazing, but I kind of wish it was microscopic? No, just me.
Okay.
Well, get this. Today we're diving into the world of diatoms,
All
a
right.
single-celled algae that are essentially nature's micro-artists.
Microscopic artists.
You provided some incredible images from troubleyard.com.
Yes, the diatom arrangements, yeah. A fantastic example of finding beauty in unexpected places.
Seriously, those images are like something out of a Victorian art book,
Right.
all these intricate patterns, and to think they're made from algae.
Algae.
It really challenges our perception of art, doesn't it?
Yeah.
And it underscores a key point. Diatoms, while tiny, are capable of extraordinary things.
Yeah.
Okay, so back to basics for a sec. The Wikipedia article you provided mentions that diatoms are single-celled algae, but they're not just hanging out in ponds.
Right. They're found pretty much everywhere there's water. Oceans, lakes, even soil.
Really?
They're one of the most widespread forms of life on the planet.
Oh, and here's a fact that's going to make you see them in a whole new light. They're responsible for something like 20 to 50% of the oxygen we breathe.
It's true.
That's every other breath, potentially, thanks to these little guys.
It's incredible to think about, isn't it? Their impact on the global ecosystem is profound. They're not just floating around, they're fundamental to the very air we breathe.
Speaking of floating, let's talk about their glass houses, these silica shells they build around themselves. The Wikipedia excerpt calls them frustules, and they come in all these crazy shapes.
Those intricate structures you admired in the arrangements, those are the frustules.
And apparently the shapes are a big deal when it comes to classifying them. The article mentions centric for round ones and pennate for the elongated ones.
Yeah.
I'm already starting to see why scientists need entire textbooks just to keep track of them all.
From an ecological perspective, those silica shells are fascinating. They're actually very energy efficient. You see, silica requires less energy to produce than typical organic cell walls. It could be one of the reasons they've been so successful.
It's mind-blowing when you think about their impact on a global scale. The Wikipedia article even mentions something called the silicon cycle, which diatoms essentially drive. Okay, so they're building these intricate glass houses, pumping out oxygen, and now they're controlling entire cycles in the ocean. What is this? Microscopic house flippers shaping the global market.
That's a great analogy, and it highlights just how interconnected everything is in the ocean.
Yeah.
Imagine a bustling city, right?
Okay.
Diatoms are like the architects and the construction crews constantly building and demolishing those silica structures. And this constant turnover of silicon influences everything else. What other organisms can thrive there, even how much carbon the ocean can absorb.
So it's not just about the silicon itself, it's about the ripple effect their life cycle creates.
Precisely. The Wikipedia article mentioned a boom and bust life cycle. Diatoms have these massive population explosions called blooms, followed by periods of decline. This cycle is like the city's economy constantly fluctuating, impacting everything else.
These little guys have been busy. They were around during the Jurassic period.
What?
Okay. Did they bump silica shells with any dinosaurs?
They were definitely around back then, though their big takeover of the silicon cycle that happened a bit later. There are a few different theories about the exact timeline and what caused it, which is what, keeps us researchers on our toes.
Always more to discover. Okay, get this. Apparently, diatoms and humans share something called the urea cycle.
It's fascinating.
How does that even work? We're talking about algae and people.
It's a fascinating example of how life on Earth shares these ancient connections. The urea cycle helps us break down nitrogen, which is essential for building proteins. It works a bit differently in diatoms and animals, but the fact that we share this fundamental process is remarkable. It speaks to a shared evolutionary history, this deep connection that goes beyond what we might see on the surface.
That's amazing. Kind of makes you want to look at pond scum with a little more respect.
I've always said never underestimate the power of the micro world.
I want to circle back to those diatom arrangements for a second. You mentioned they make us rethink art. What is it about them that has captivated people for centuries?
There's a certain elegance to their simplicity, I think. These intricate, symmetrical patterns, they tap into some fundamental aesthetic principles that we find naturally pleasing. It's like our brains are wired to appreciate this kind of natural beauty, even at a microscopic level.
And that beauty, it's not just skin deep, is it? It's a gateway to understanding their ecological importance. It's like those diatom arrangements are a reminder, beauty can hide in plain sight. And often it's the smallest things that have the biggest impact.
Absolutely. Diatoms, they really remind us that appearances can be deceiving.
Yeah.
We see these intricate patterns, this delicate beauty, and it's easy to overlook the powerhouse that lies beneath.
We've talked about their oxygen production, their influence on the silicon cycle, their ancient history. But there's even more to these tiny titans, isn't there? The Wikipedia article you provided mentioned something about nanotechnology.
Ah, yes, that's an area of research that's really starting to take off.
Okay.
Scientists are incredibly interested in diatom's ability to build those silica shells with such precision. We're talking about structures on the nanoscale, far smaller than the width of a human hair.
So what could we, learn from these microscopic engineers? What are the possibilities?
Imagine harnessing that silica-producing power, right?
Yeah.
We could potentially create new materials with incredible properties. Lighter, stronger, more sustainable. There are even applications being explored in medicine, using diatoms for targeted drug delivery or creating biosensors.
It's like something out of science fiction. We started with the microscopic art, and now we're talking about, revolutionizing technology. It just goes to show you never know where a deep dive will take you.
That's the beauty of it, isn't it? Every time we delve into the natural world, we uncover these hidden wonders, these reminders that we still have so much to learn.
So to recap, we've learned that diatoms are not just some, boring algae.
Oh, no.
They're master architects, oxygen factories, ancient relatives, and now, potentially, the key to unlocking new technological frontiers.
Wow.
All of that in a package so small, you need a microscope to appreciate it.
And hopefully a renewed sense of wonder for the world around us.
Absolutely. Well, that wraps up our deep dive into the world of diatoms. Big thanks to our expert for guiding us through this amazing landscape. And to you, dear listener, for taking the plunge with us. Don't forget to check out the show notes for links to those incredible diatom arrangements, as well as more information about the research we discussed. Until next time, keep exploring and stay curious.